Okay, sir, I will start here. Okay.
Okay.
Yeah, okay. So, good morning, Dr. Ravishankar Dudhe, and good morning to the participants who are watching this live session. So, welcome everyone to today. Our session is on technological advancements in VLSI. So, VLSI technology has profoundly transformed the electronics industry over the past few decades and enabling the development of circuits that are more powerful, smaller, and more energy efficient. This session is designed to explore the cutting edge advancements in VLSI that continue to push the boundaries of what is possible in microelectronics. From the latest in chip design to breakthroughs in semiconductor materials and manufacturing processes, we will delve into the how these innovations are shaping the future of technology. And the field of VLSI has seen significant evolution, particularly in the areas of chip density and design complexity. And modern VLSI chips can contain billions of transistors on a single chip, which has far reaching implications for the capabilities of electronic devices. And in this session, we will examine the key developments such as FinFET technology, 3D integration, and the transition towards smaller nanometer design, which offer substantial improvements in speed, power consumption, and functionality of integrated circuits. These technological leaps are not only pivotal for consumer electronics but also for applications in AI, automotive, healthcare, and telecommunications. Furthermore, this session will address the challenges and future prospects in VLSI technology. And we will discuss the issues such as scaling limitations, heat dissipation, and variability in nanoscale dimensions, as well as innovative solutions being proposed to overcome these hurdles. And additionally, the impact of emerging technologies like quantum computing and flexible electronics on VLSI design will be explored. And through the detailed discussions and expert insights, the participants will gain a comprehensive understanding of the current trends and future directions in VLSI technology and preparing them for the next wave of innovation in the field. So before we start Dr. Ravishankar's session, I would like to give some short introduction about him. So we are privileged to have Dr. Ravishankar Dudhe as our speaker today. Dr. Ravishankar is a distinguished figure in the realm of sustainable energy and academia and boasting an illustrious career that spans over 3 decades. And he earned his doctorate from the prestigious Indian Institute of Technology, Bombay, and currently serves as the PhD coordinator and associate professor and senior scale at the School of Engineering and IT at the Manipal Academy of Higher Education, Dubai campus. In addition to his academic roles, Dr. Ravishankar is deeply involved in research coordination at the campus and continually pushing the boundaries of innovation and sustainability in education. And Dr. Due's commitment to sustainability is demonstrated through his active participation and leadership in various projects that aim to foster an environmentally conscious mindset among the students and the community. And he led a team of students in the Deva Solar Decathlon ME 2021 to design a net zero solar powered house and showcasing his dedication to practical applications of sustainable technology. And additionally, as a coordinator for the Energy Swaraj Foundation, an initiative started by IIT Bombay, Dr. Tudes works tirelessly to promote the energy literacy and self sustainability. His efforts have empowered the over 1,500 students to become solar ambassadors, gaining hands on experience in solar lab assembly. And beyond his projects and educational initiatives, Dr. Ravishankar is a prolific researcher and author with over 50 research papers published in internationally reputed channels and conferences. And his research interests are diverse encompassing fields such as VLSI, smart and sustainable practices, IoT, and happiness and well-being, and organic electronics. He has authored several books on topics ranging from analog electronics to satellite communication and organic field effect transistor based electronics, nose platforms for explosive detection. A multiple recipient of the Excellent Faculty Awards, Dr. Tudhe's influence extends across the several advisory boards and editorial review committees, and he holds lifetime membership in prestigious organizations such as ISTE, ITTE, and IET. His dedication to his field and the well-being and happiness of those around him and highlight his holistic approach to education and sustainability, making him a beloved and impactful figure in both academic and professional circles. At the end, I would like to introduce to the motto of Dr. Ravishankar, empowering sustainability and enlightening minds. I would like to hand over this session to Dr. Ravishankar, and also thanks a lot for joining us today. And over to you, sir.
Thank you, Sarim, so much for introducing so big. Actually, that is not needed, but thank you for that, and thank you for providing opportunity to interact with the young children's young minds and letting them know the technology. I'm sharing my screen. I hope it is visible. It's visible screen. Good morning, all of you. I hope the screen is visible and my voice is also perfect.
Yeah, yes, sir. Everything okay.
Yeah. So I'm thankful to Mastering Up for providing this opportunity to interact with all the participants present here. And the purpose of this is to give you technological advancement in VLSI. Because as we move on, we are looking for self-sustainable solutions which take care of the sustainability. And when we talk about the sustainability, we always have to understand various aspects. First aspect is I never want anything to be costly. I don't want anything which is abusing the environment. We do not want anything which consume lot of space. We do not want which is slower. We want faster. We want all lower consuming, power consuming, energy consumption will be less, and also cost effective. Over and above, we want that to carry in our pocket means the packing density should be higher. And what else other than the VLSI, which called very large scale integration? That's the solution. And whenever there is a solution, whenever there is opportunity, challenges are there. But why this opportunity and challenges, how it is going to help us? Yes. So this particular talk is oriented to know yourself how you can make ready for industry, job availability, where you have to dig more in order to get the outcome and you are aligned with the industry. Recently, you might be knowing in India and across the world, semiconductor industry, how it is progressing, how it is required, how the foundries are set up, how the new industries are brought in. These are all because when you are looking for the sustainable and smart future, without technological advancement and getting involved in that technological environments, we cannot proceed. Few handful of people cannot do the change. Everybody has to come into picture, and therefore we say it should not be a mass production. It should be production by masses. Means everybody should involved in technological evolvement, and then we can get a best outcome to avoid so-called, oh my God, many problems we face. And once the problems affects us, we say, oh my God, it is so hard, it is so problematic, it is time consuming, it is cost, I have to put a lot of in. These are all called oh my God. To avoid oh my God, we have to follow the concept of AMG to avoid OMG. AMG always is A stands for avoid. What avoid? Whatever is not possible, whatever is not required, sorry, not required, truly avoid it. But that you should be intelligent enough to understand what is required, what is not required, what is your need, and what is your grid. Another, if you cannot avoid, then minimize. And there the role of technological advancement comes. Minimize in what? Minimize in area, minimizing power consumption, minimizing cost, and minimizing in delay. These all things is possible through VLSI. And then think about generate. Generate means typical applications for our typical hardware come software combinations for those applications we required. And yes, so therefore this topic which we selected is intended to make you aware about how the job seeker in semiconductor industry can take advantage of this latest trend and what is VLSI technology. So I'll be taking you through some of the facts and figure and let you know, understand how this VLSI can become uh, bread and butter. And not only that, you are going to be useful in society. So as a human, we have to return back to the society. So here we'll explore some of the new technologies in VLSI design, which will be useful for job seekers. You look at this, whichever field you talk about, VLSI making an impact, VLSI becoming essential. It has already become essential and it is already at place, and technology is so advanced, it is beyond the imagination. Talk about the nanotechnology, we talk about the chip. In a chip, you can see this. In a chip you can have 10 raised to 11 to 10 raised to 12 devices. That many devices mean the size of devices in nanometers. You just imagine. So since this makes technology useful, viable from the all four perspective. Again, I repeat, the four perspective is the speed. You do not want the compromise in the speed. You do not want the power consumption to be high. You do not want the occupying space to be higher, and cost. These are the four pillars, and this technology fits in. And it uses a very good concept which is in place called IoT. It is called Internet of Things. So well connected with this, we'll see that how these things are there. So very first thing, the first advancement is advanced semiconductor processes are available. Now what does it mean by advanced semiconductor process? When we talk about the nano level devices, when we talk about the devices which are very tiny devices, now how it to be manufactured, how it to be checked, how it to be processed, what are the requirements for manufacturing those devices, what are the advantage is with the advanced semiconductor process. That is the first thing, and we get aligned with this advanced this thing. Of course, the industry needs skilled people with that. Another advantage, another good thing is AI and machine learning is effectively used in VLSI design. So what is that AI? And all of us know AI when we talk about the artificial intelligence, the way we think, the way we want to implement, way we want to get it done. That same thing is possible in the VLSI, getting the data, storing the data, analyzing the data, based on the data, developing and the protocol, everything. And with the help of machine learning, you always can optimize the requirement and take a call, take a decision based on that. Let us say I give one simple example. Let us say I'm driving a vehicle, and in vehicle I want certain things to be automized, which we are, of course, the requirement now. We are looking for the autonomous vehicle, we are looking for the electrical vehicle, and so many of such autonomous functionalities in various requirement. So in that case, we need certain thing to be taken care by the machine itself, and that revolutionary chip design process is possible in VLSI, and it's already in use. So what it does, it takes unknown input, then it go and check with the already existing such kind of stored database, and based on the threshold limit crossing and all, action can be taken. What the way we do is the same way can be done. So I was talking about the example of a car. So in a car I am driving, so I want somebody is coming in front of me and I cannot see, the rowdy driver can come and dash me. But such kind of autonomous, what it does, it has in the vicinity of 1 kilometer or something. This is again in vicinity of 1 kilometer, I say, because we don't want to get limited by the Wi-Fi available. So we have XB Zigbee kind of chips, where we can have the protocol for transmission of wireless data without presence of the Wi-Fi, can be up to 500 meter to 1 kilometer. And in that case, the data is available in every car with the help of GSM modules present there, and it tells you the any vehicle around you in the vicinity coming towards you, in which direction, what speed, and everything. So you can be aware about accidents which may happen because of others' mistake. This is what simple example I'm giving, and uh, that basic thing needs AI and machine integration in a chip. A lab on chip concept is there, means you can have a complete lab on a chip to get the optimized performance, to reduce the power dissipation. And very important is, whatever you are thinking, you should be able to put them in the market at minimum time required. That is, you should have a very high speed integration, so that time to market should not be too long. Otherwise, by the time you market, the product is out by somebody else. So VLSI allows that. It not only allows that, if you are talking about the high packing density, let's say mobile, in a chip, you have so many of the modules present there. Some modules for the power, some module for the video recording, some module for the voice recording, some module for the handling input and output things, some one for a touch module, everything. So a good floor planning is possible, means how to effectively place the components, IC, everything inside the chip, so that we get optimized utilization of the space and get the maximum efficiency. That is possible in VLSI, and this is the latest trend going, which if you are learned in that, you are required. Another important thing is 3D integration. Very important concept, because the most of the 3D implementation techniques which are available in VLSI makes you to get a multi-layer functionality, multi-layer chip fabrication. And multi-layer means one layer, second layer, third layer. You can have up to 9 layer, 10 layers, and with that, and this is all on a nano scale. So you can have a communication between one layer to another layer. One layer can be optimized for, let us say, transmitting of data, which is a very secure. Another layer for another functionality, and this all vertically with the 3D is possible. A connection is provided from the vias. Vias means metal to metal connections and all, and this gives reduce the footprint and higher performance compared to 2D devices. That is the beauty involved. It is available in VLSI technology. Okay, this is the latest requirement. And another thing is you have photonic integration, very important, because data transmissions have various mechanism by which the data transmission is. And one of the mechanism now in present for the secure data transfer and for reducing the latency, means the delay, and for energy efficiency, one of the very important thing is transmitting the data with the help of light, called Li-Fi, also light fidelity. That is one of the important concept, along with the other techniques for data transmission. VLSI has that photonic integration already at place, and that makes a very, very useful technology for current trends brought in, keeping all the aspect in mind. Sustainability means energy consumption should be minimum, high speed data transfer, security, because we have so many applications running around, so many users are there, so many data around you, and the integration of the data with the security, if it is not taken care of, what happens is mess up of the data. You are using the cloud for storing the data, and then data start communicating with each other. That is called the virus, the data. That level of security we need, and VLSI allows that technology, which allows you for secure data transfer and uh, fastest data transfer. So photonics, photoelectronics, it is called photoelectronics, means with the light. Okay, so you have the laser sensors, you have the optocouplers, opto-isolators, then transmitter, receiver, everything optimized in the VLSI, integrated in the chip. It's not this. So that is the another advantage we have in the technology present. Okay, the another thing is very important is quantum computing. That is the revolutionary outcome. The quantum computing gives all the advantage which are actually limited in the classical PC which we use. There are, it, of course, digitization makes made us use effectively the platform, the memory, the computing facility, and everything. But quantum computing has given the upper hand, because it has not only the two logic level, it has the different logic level based on the quantum levels we defined. And because of that, what happens, your computing time becomes less. Of course, that require lot of study, lot of orientation, understanding what are the quantum mechanics, quantum processes. And VLSI has progressed, advanced in a level where this quantum computing is already embedded in that, because of multiple functionality parallelly you can do, simultaneously you can do. So computational power required increases very high, and VLSI allows you to handle that power which uh, do not go beyond the limit. And that is called power down technique. There are various techniques VLSI supports for understanding how the computational power can be kept in a limit, so that we, even though doing the multiple functionality, we do not indulge in getting lot of power wastage. One, another is when you are talking about the multiple communication, complexity of that data, complexity, communication between them become complex. VLSI again help us to reduce the complexity, and therefore it gives the all these problems which are complex problem, computational problem, enabling solutions, has the exponential rate faster than the classical computers. This is one very hot area in the VLSI, quantum computing, which is. And this quantum computing, when we talk about, it is data available, processing available, but how you fast communicate at on site, you are doing so much fast calculations. But what about the transmission? If factory is generating so much of the production and you are not having any way to transport to the other place, and then it's getting limited by that, that will put the bottleneck. VLSI going 5G and beyond. 5G and beyond. So what it does, it has this that speed limit overcome. So transmission, data transmission at the high speed with the complexity involved with the quantum calculations and all is possible with the 5G and beyond. That is already a part and parcel of the VLSI. What it does, it gives VLSI very significant because we are looking at the technologies. We can integrate multiple applications. You can look at that. You can look at the autonomous vehicle. You can have the operating smart devices. You have the smart energy. You have the smart building. You have the smart medical facilities. You have a virtual reality. You are talking about the some transportation mechanism. You talk about the fastest Wi-Fi communication. These are all comes under 5G and beyond capacity of the VLSI. How it does this basically? It does by reducing the latency. What is latency? Delay. And that is the beauty when we have mechanism how to reduce the delay by maintaining the low power, the best thing. Because what happens in a technology, when you try to increase the speed of the communication or speed of the data transfer, your speed increases but along with the power consumption increases. However, if you are reducing the power, then speed reduces. So your power delay product becomes the figure of merit for any technology, and VLSI gives that gives upper hand to be used in autonomous vehicle, augmented reality, which are the futuristic technologies. So that is another advantage. So what are the trending technologies? Latest VLSI technologies, latest VLSI technologies which are trending. Very first is called edge computing. Another is security and trustworthiness. Third is neuropharmic computing. Let us see one by one in brief. First is edge computing. When we talk about edge computing, how it helps in getting overcome this kind of thing. So when I talk about, or when we talk about the edge computing, edge computing is a trend in the VLSI technology driven by increasing demand for processing power at the network edges. So we have the very large network. As we are talking about, we are talking about millions and trillions of the devices in the small package of, let us say, 2 centimeter by 2 centimeter. And there we have to understand how the processing power can be optimized by demand requirement, as per the demand requirement. This edge computing is one of the technology, one of the trending technology, which makes you to understand how a network edges where the most of the communication is supposed to happen, in how it is satisfied. Here, how this is done? This is all computational resources, which are all means maximum, you can say maximum computational resources are moved towards the place where data is generated, because data is so big, it's a big data, and data computational. If you take a data, let us say I am at place here, and my data what I receive is something around 10 kilometers from here. From there I have to get the data at my place, then process, then transmit again back. It have lot of power requirements, lot of your requirement of other modules to support that one. So those kind of supporting scheme makes overall speed low. But in edge computing, what is that? Wherever data is generated, your computational resources are deployed near to that. And that's what the advantage sometime before I talk about. That is floor planning, means which module where effectively can be placed. That is advanced technology is possible. And that makes very important thing, effective utilization of the bandwidth and reducing latency. Again, latency means the delay in the propagation. It should not be like I press the mobile button now, and after 1 minute I'm getting the response. We do not want. We want, actually, we are thinking like that. While my thinking, my thought process itself should start some action. That's the way we are looking at the technology. Yes. So that is possible by reducing the internal delays, and that is the key concept used in edge computing. So here VLSI designers are tasked with creating low power, high performance chip tailored for edge computing application. So here indirectly I'm telling you, if you are good, skilled in doing this one, creating low power, high performance chip tailored for this application, you are required by n number of industries. So this is one of the skills those who are looking for getting their job perspective enhanced in the field of VLSI, which is actually the brighter field, which is used in every applications which talk about. Of course, when I'm talking about the every application, it is in the smart environment, smart city, smart country, sustainable environment, and smart, sustainable, and secure. This all is the requirement, and this is possible by advancement in technology, learning what is the requirement to mitigate the problems or the challenges which we are facing in progressing towards those requirement. Okay, so that is one of them is edge computing. Another is security and trustworthiness. As all of us know, as the number of users increases, number of devices increases, number of complexity increases, number of technologies increases, number of service providers increases, integration between them, transferring up the data from one network to the another, and so many things are there. And in that, how to trust, what to be done in that. So we cannot rely on the third party. We have to make a system, or we have to make the technology in a way like we ourselves provide some of the mechanism by which we have trustworthy data, irrespective of which medium, which service provider, which protocols we are trying to use. But yes, that is what you are requiring skilled development. So VLSI technology ensures the security and trustworthiness by focusing on the critical areas. So let us say my body has some problem. Let us say I'm talking about the cancer treatment. And the cancer treatment, cancer is a very painful treatment that is called, what is the cancer treatment called? That is chemotherapy and all. So what it does, it actually make every cell around that cancer cell die, and that is a painful part of it. But advancement in the VLSI nanotechnology, you can have the nanoduct delivery. Means you can go to that place where that cancerous cells are there. You can take the picture. You can study that particular place by inserting the nano cameras and understanding those features of that, and delivering drug exactly at that point. Nano delivery. So critically focusing the area is one of the thing. With the rise in cyber threats, it is imperative for the VLSI design to incorporate robust security mechanism. It is requirement. And how it does? It does by encryption techniques used by various VLSI protocols. Encryption means that data, before sending, you encrypt it. You make it temper resistance, means nobody can temper that data, so it is very secure. Is all this thing. Okay, you can have a safeguarding sensitive data and prevent unauthorized access. These are key words, key areas in which VLSI provides upper hand to do those things so that your data is secure and trustworthy. Irrespective of, again I'm telling you, what are the different users, what are the different protocols, what are the different system it goes through, what are the different mechanism of transmitting of the data. All those things are the challenges, but we have to look at what are the ways I can make it a best cyber secure data, how I can make that the make people disabled. Who people? Those who are looking for tempering your data. Okay, the hackers, we make them disable. or we make them, we throw the challenge to them because they are four step ahead of us. So as a technology designer, as a application developers, we have to be careful to give them the challenge. Hey, now this secure data is there, try what you can do. Okay, that kind of thing. And that is possible by learning new technologies, new algorithms for encryption, temper resistance designs, possible, available, used in VLSI. That is the trending one, second trending one. And the third is very important is neuromorphic computing. When we talk about the neuromorphic, I think by the name we can get it. Okay, basically it is a very latest or useful cutting edge trends in VLSI, which mimics the architecture and functionality of the human brain in revolutionizing the computing. Because human brain can think, can compute, can do lot of things, but mimicking that is a challenge. In neuromorphic computing, this is all things are developed, and therefore the AI based system are coming up with implementation of all those action taking mechanism, emotional outcome based on the process, thought process, action to be taken. If any input suddenly comes and you need to change the plan, yes, that is possible. These are all called neuromorphic computing. So this is one of the trending, you can say, branch, where you get skill, you get learned, you get yourself make ready, so that you are acquired very highly. Because this kind of changes when you are doing, you are actually aligned with the AI, you are actually useful person in the company, in the industry for that. Here, how it is done actually? It is done by emulating neural network directly in the hardware, and your system which offer the higher efficiency and scalability, which basically based on the pattern recognition and adaptive learning. So when I go and see something new, if I'm seeing the first time, probably I'm not able to recognize, but that data gets stored and multiple data gets stored, and then for that I create some typical, you can say, pointers in my mind. And whenever I see that thing next time, automatically what happen, the sensors, my eye take the data, give it there, by neural network go and compare with already stored something, and it found the match. Oh, that is good, that is the same thing I was, so they say, oh, this is the snake, I know that one. But something new comes, then it compare with the already existing thing. And adaptive learning means it takes guesses, it could be like this, and check with the errors, and if the errors within the limit, you proceed. If not, then do the feedback mechanism and then modify it. These are all things are the part of neurolearning. And this emerging field holds immense potential to transform various industries like healthcare, robotics, healthcare, use of the healthcare in robotics, enabling intelligence, real-time decision making at the edges. You see the robots are teaching, robots are cooking, robots are this. Here, this technology, which is neuroformic computing, is a trending one, very trending one, and very useful to move ahead. So what are the future jobs in VLSI? If you are a specialized skill set, you have the specialized skill sets in VLSI, highly demand. What are those? You need to have a physical design kind of softwares in place. You should have analog mixed mode design expertise. You should be very good in verifying the logic, or you should be good with the those kind of softwares which use for the verification of the chips and utilization of that. Okay, so that skill, if you are there having you are always required in this dynamic industry. Another is global collaboration and remote work. So So you have to see your work is not limited to you, because all the places, all the facilities are not available. So you should not limit yourself to the boundaries of your work. You have to see what are the things we do not have and some other people have. So have the collaboration with that, have the technology collaboration, have some part you do, some part they do. It's called global collaboration. It is for preventing the bottleneck in the technology. So global collaboration and remotely working, that is also work from home after corona has come. This allows, and but we should be skilled, we should know. These are all today what I'm talking about, giving you the pointers. You can look into pointers and find out what are the things needed to get involved in that. And if you have one of the thing in your hand, in your CV is added, this one, this I know, your job, your requirement is very much there in the all upcoming industries. Correct. Another is cross disciplinary expertise. I cannot say, hey, I am electronics engineer, I am mechanical engineer, I am computer engineer. I know this one. I know I'm civil related stuff. I know, or I know business things only. I know technology which are used for the progress of the business, economical thing. He cannot say that. It is actually the mastery should be there, or at least you should be involved in the team where all cross disciplinary expertise are available and you develop few of them. It could be material science, because when we talk about different requirement, the material becomes a very essential, because heat which is developed. So materials which do not generate much heat and also able to give you a fast processing thing. So material technology, the physics involved in all those technology, software computing, all those things come from the different interdisciplinary aspect. So that is one of the futuristic jobs available. Along with that, there are security challenges. There are challenges in the VLSI horizon. One is power consumption and heat dissipation. That is what we are talking from the beginning. We are saying that, but as the transistor size becomes smaller, the power consumption becomes the critical challenge. And yes, that has to be understood, or and understand the solution, innovative solution. We keep coming, studying and making ourselves update about those power consumption and heat dissipation technology. So this is one of the research area where if you get yourself updated and start using those, you will be one of the solution provider with facing the challenge. Security concern in VLSI design is always there, cyber security. So as already is, discussed, and we should know what are the different encrypting protocols, what are the different processes to be done in order to make my data secure. Environmental sustainability, very important. You cannot go on making the chip which are not reusable and thrown in the environment. You cannot make the chip bigger and bigger. You cannot make the over power consuming this. We cannot go on just generating as many as possible and then giving the carbon dioxide to the environment and go on abusing the environment, go on increasing the global warming, go on violating the rules of so-called Paris Agreement, where we want the overall temperature over the industry standard not go above 1.5 degrees centigrade. We are not at all aligned with the sustainable development goals. Probably you know that there are 17 sustainable development goals, where hunger, minimum energy, the use of the technology to collaborate and get the people, those who are in the remote place, involved in this technology. Everything eco-friendly, everything has to be done to keep the nature in mind. We should not abuse the nature. So these are the challenges on your horizon. Applications, when you talk about infinite application, anything you talk about, applications are available. So when we talk about IC industry, the integrated circuit industry, consumer electronics, I think I don't need to talk about infinite. Wireless and wireline applications, VLSI sitting there. Electronic design, automation, any automation you talk about, any automation, it is the heart. It is the heart. Medical electronics, yes, actually it is revolutionized with the help of VLSI, because as I told, nano drug delivery, that is one of the points I told. But there are various way. Whole body was exposed to X-ray, and this, and now we don't have to. We get a particular place, and then you can go. And the various treatments are provided without the use of the drug are given to the patient. But there are some methods, some things are evolved. So medical electronics is that automotive electronics. We know autonomous vehicle, we know electric vehicle, we know so many things, the autopilot, the plane, and then so many transport things which are because of the VLSI becomes essential in aerospace, defense, MEMS, micro electromechanical system in bioelectronics. So recently, yesterday only, not yesterday, some 1 hour before, I was seeing one of my colleague who was there in IIT. They have developed almost cost of 100 rupees kind of injection, which can be injected in the body for taking care of so many diseases, and cost is very small. MEMS, micro electromechanical system, which are most sensitive and most selective. My PhD topic was electronic nose, making up electronic nose for explosive detection, RDX and TNT, trinitrotoluene means landmines and all detection. But these are all possible with VLSI. So we cannot limit yourself. So future belongs to one who can dream beyond horizon. And VLSI helps in dreaming beyond imagination. Being imagination. To see that, you can see, I can show one video. I think you can see that video for just 4 5 minutes, 2 3 minutes. I'll show one of the technology which is very effectively used and making our life very happy, enjoyable, and all those things. Probably it is taking time. Before that, I will tell you one more thing. I think this person. He's Sundar Pichai, and everybody know him. His latest article was three reasons why quantum computing will challenge VLSI design. VLSI design has a challenge with the this computing. What are those? These are basically, first is integration of classical and quantum components together. Very difficult because one of them work at some room temperature and another need the super cold temperature. Look at that super cold temperature. So that is a challenge. How we can integrate that? We are saying that yes, it is possible, but now challenge is that one is working at room temperature, one is that. So VLSI is helping, and we should know how we can proceed this is one challenge, integration of classical with the quantum component. Error correction, yes, yeah, quantum bits are very fragile with the errors. However, VLSI has various technology which can be taken care of. So combination of these two, error correction, but this is a challenge. Another, scalability. When we talk about scalability, means you are increasing number of users and also many, so crosstalk happens because we have so many compact devices closer to each other, and any electric field, any electromagnetic field by one will interfere with the other, which is called crosstalk, becomes the challenge. When you talk about the scalability, when you are trying to increase the number of components, when you are trying to go for higher scale in use, that is one of the challenge. And, read out complexity, very important. You have the data available with you, but do you have the reading capability? Can you read that quantum levels together and with the same speed? That is one complexity, and that is why that Sundar Pichai is telling about. This is one of the challenge thrown by quantum mechanics, quantum computing on the VLSI. And yes, we are ready to accept the challenge, because when you accept the challenge, opportunity comes to you, and you can develop yourself in that field and go ahead and become the resource person, known resource person in the field. Interconnectivity, very important, very important. I'm sitting here, I have metro, I have bus, and I want to go to one place, and then between them the connectivity is not there. There is a lot of traffic, there is no good connectivity and all those things. How I can do? So and on site you have a lot of high speed data generation and all, but what about the transmission of that? So interconnectivity is requiring the novel approach, and therefore R&D in that is a challenging one. And when there are challenges, again, I'm telling you, opportunities are waiting for you. Another is novel materials and processes. So superconducting quantum bits, as I said, they work on the very low temperature, okay, cold temperature, almost freezing temperature, 0 degree and around that. So we need some superconducting materials and for making the quantum bits. We need topological quantum bits means we need some mechanism by which you have the robust mechanism for taking care of the errors when we deal with topological quantum bits, processes, communication. So this kind of here the research is needed, and research is going in challenging material growth with the device integration. Material is technology is going one way, but making a device, integrating with that and using that is another challenge going simultaneously. Spintronic is one of the thing. Spintronics, spin electronics with the quantum mechanism. You know, when we see the quantum physics and all, we have layers in which we have the electron around that with the opposite spin and the different layer. So that spin can I use for making my progress in this one? Yeah, this is one of the things very important. So navigating new frontiers, taking challenges head on, the world of possibilities. This all comes with the crucial role of the semiconductor which is played, which addresses all those things. So semiconductor industry is the future. You cannot directly b- blindly go ahead with the technology which is not looking at the challenges. So these are the challenges thrown in front of you. So I was trying to show some video, but I don't know whether it is still on or not. But anyway, yeah, it is there. So you can look at this one of the thing. I will narrate in a brief. So this is a advertisement about a company which talks about the future technology. Look at vehicle, which is with the all technology embedded in this. Okay. So just showing this is the advertisement by the company. Now look at the person who is driving. He will come. He's come down and he use technology for going from one place to another, because we know as we are proceeding further, the traffic and all those things is the problem. We cannot take vehicle everywhere. So what he does, look at that. He confirms that he wants to use this another mechanism for that. He stood on that from the vehicle. He took it and going for the place where he wanted to go for that. Okay, then he can have that vehicle automatic parking. He doesn't have to do anything. Automatic parking is there. This is all possibility because of the electronics VLSI possible in our technological advancement. And we are skilled person. Now he can see, don't need a classroom, don't need a place for special place for meeting and all those things. He is using the that dome and the structure which is already available, can display the his instruction and discussion with them. Look at that, his family is going out, and in the car itself there is a place for children to get entertainment, but it is all under the control of parents. Okay, it's not like children get spoiled. Now they are very close to the home. They are trying to go. So he has finished this meeting and trying to go and meet his family. So now he will go inside, and then this is um, face recognition was one of the concept. He's going toward the office. He put the office location. He's trying to go for that, as well as he's trying to see where his family members, where they are there. So he'll try to see everything, so they know, oh, they are there. He's getting ready for the school, everything. Okay, so no need to wait for that. All informations readily available with the technology. Okay, so here they are going somewhere. They are reaching near the home. Just one thing I just wanted to show. So they are going. So cooking should be ready. So remotely they turned it on. By the time they reach home, everything will be available, ready. He hot thing. Go eat, enjoy. Then they are trying to go for some picnic or somewhere. If they are going, uh, they are trying to go somewhere, and the place they wanted to go is not known, but technology allows you to know the pros and cons of that place. This all, this guy is having some technological things, and he's scanning that and he's trying to understand where what is there. Oh, this kind of things are here. Either you want to go and get closer to them or run away from that place. This all things possible with the technology. He's doing the scanning of those all those things and start treating them. Everything is possible. Means he's trying to go meet his family, but he's doing the task. He found that somebody needs some treatment. He has provided some treatment with the help of VLSI and those kind of technology advancement. Now they are going for the picnic. The child is very excited. He's trying to go. He's trying to open up this, but he will not because there is security involved. Unless until the parental controls are there, he cannot do. So those are security levels. Only parent can help. Now they are inside the car. They have selected the scenic road. They don't want to go by the boring road. They are going for that. They started moving on. Child is not liking that road, so he is going by the scenic road. But he wanted to change the location. He will do that something. This road is not good. He will change. Hey, leave it. I want to go to some other place. So he got that one. Yes. So vehicle is on the other road. Now vehicle is trying to cross, let us say, the river somewhere. However, his father is knowing that where they are going, so they are well connected. Now the car is trying to go through the river, but or something. The how deep is there? Yeah, is it good to go from there? So they will have some mechanism by which they will identify whether the sufficient space or good point to go there or not. Identified. Oh, that is safe. So he will put in the vehicle. It's not like in the rainy season we put our vehicle and we get stuck. Every technology is possible. I will not go and do. I tell you, this is the video I played. It's called Future Technology in Electrical and Electronics Engineering. You can see what you think. Now he is tired and he wants to go. So he put that vehicle in autonomous mode and he will, yes, autonomous in and drowsiness. So he will relax and vehicle will take him to the destination wherever you want. So and the child is enjoying his natural thing with that. There is a protection, auto protection for this stone falling on the vehicle. Everything is possible. In fact, I will not go beyond this certain thing because there is a time limit. I have to stop here. But I think that gives the idea how the technology is taking you ahead and making you aware. The advancement in the VLSI technology is good. It is making you think beyond the imagination, beyond the horizon. So don't get yourself limited to this. Go ahead with the VLSI technology. Learn, make yourself skilled, and make yourself skilled to be used and get yourself job, best job, which makes you feel earning better and along with the technology and be happy. So I will stop here. I'm stop sharing. I will stop here for this talk because it's exactly almost 11. I have to stop. So I hope I made you some insight about what are the technological content available, where you can go ahead, where you can get the job, what are the opportunities available. But do not get one last thing I will talk about. We know fear. Don't get fear. Fear stands for two definitions. One is forget everything and run away, which is normally we do. Because whenever challenges are there, we forget that we don't want to face them. Instead of that, what you do, another definition of fear is face everything and rise. So you face the challenges and then there is opportunity to rise. So that's all from my side. And always go ahead and try to get yourself skilled and be happy. Enjoy the sustainable and smart future, secure future for you, waiting for you. So go ahead, don't wait. Start running from the day. Thank you.
So thank you, sir. Thank you for the wonderful presentation. So I have some questions here.
Yes. So
Yeah,
some questions are there. If that, I'm happy to answer them. If you read for me, if from where if any questions are there, yeah.
yeah, sure. So, what are the key challenges and potential solutions for integrating quantum computing elements into traditional VLSI architectures?
Very important question and very useful question. Very important thing. One of the challenges is when we talk about the quantum computing, this one challenge is the operating temperature. The VLSI and all, it can work on the room temperature. However, the quantum need a very cold temperature. So when we are bringing this together, how two technology at different temperature can be brought in, this is the one of the very critical challenge. One. Another is when we talk about the computing with the quantum, it's very fast. So, and since it is very fast, it's a multi-level this thing. And when we are going for the multi-functionality, there are so many layers are there to work together. So that complexity of working together, the computing, parallelism, all those things together, how we can do with keeping the data secure, that is the another challenge. Of course, there is an opportunity for that also in the challenge. That is the next challenge. Third is, when we talk about the quantum, it is prone to noise. It's not like VLSI. Okay, so noise gets very fast attacked by that. So how it can be done so that we make use of the advantage of the quantum and use VLSI along with that. These are three main key challenges. Solutions are there. R&D is there. Material is one of the options. Looking for the different material which works very coolly, doesn't get affected by temperature. So material technology, material science is one of them. Then various secure protocols, understanding them, encrypting technology is another solution for that. Yes. So this is, I think there is these three which I told, these are the major challenges in this thing. And that Sundar Pichai's one article which I shown is actually talking about those challenges. So anybody can go through that. But anyway, these are the challenges, but with the opportunity. Go ahead in the future. Yes.
Yeah, okay, thank you, sir. So, how can VLSI design contribute to the advancement of artificial intelligence hardware, particularly in developing energy efficient AI chips for the edge devices?
Very important question, because when we talk about the integration of that, we have to very importantly talk about how we can minimize the energy. Energy conservation is the very important concept. So VLSI, how it helps. Basically, when we talk about the AI, we know, let us say at my home, I have the AC running on and I went out and I forgot to turn it off. So I have a IoT based solution which keep tracks of power consumption continuously, and whenever it is beyond the threshold limit, there is an action automatically taken by the PLC and contactors which is embedded in a VLSI based chip. So what it does, it takes the data and takes see that whether it is in the control and it is going beyond the temperature. If it is like that, automatic the mechanisms are invoked which will pass the coolant and takes the heat away, so that overall temperature goes down again and remains in the this limited things. And as the temperature increases, the limit with which the data transmission also decreases. But when we take care of that, what happens, the data transmission rate also increases. So this is one of some techniques I told. So there are techniques, because human can think, that has to be embedded with the artificial intelligence, and by VLSI helps in making the all those protocol for pattern recognition and transmission, that is made easy available with VLSI. That helps to get actual AI embedded to take a call, take an action, did not should not depend on human and other thing. This is how VLSI protocols and all helping to go with automation, help of AI, and going towards net zero. Net zero means that not abusing the environment, not emitting lot of thing, only go with your need, not with your greed. VLSI helps in that. Okay, so that's a very important thing people have to understand, because without that, you are trying to go and use as much as possible, emit so much of the carbon, and make your future dark. Instead of that, understand, reduce the energy consumption. Future belongs to you, means you are not abusing the environment.
Okay, thank you, sir. Sir, what role will VLSI play in the future of wearable technology, and how can design be optimized for wearables?
Just in bit voice was breaking, so can you take one keyword which you are asking?
Sure, sure, sure. What role will VLSI play in the future of wearable technology, and how can chip design be optimized for wearables?
Yeah. So basically, when we are talking about the virtual world, so anything, okay. So where what I'm thinking now, let us say I'm sitting in front of you, what I'm thinking, I want that to appear in my screen, and my thought process itself should be able to control that and all those things, because we are becoming lazy and lazy day by day, correct? And technology is using us instead of we use the technology. So VLSI makes you give the control to have the control over the technology, not the technology start controlling you. But what is the important thing? You have to get aligned with the requirement, you get skilled and start using. So technology controlling, proving that it is, though it's virtual, but it is used by me, not by anybody else. I'm not controlled by somebody else, I am controlling that thing. And that part need a child want to control that vehicle by himself, correct? But for that, what is needed? He should know na what are the things to be done. So VLSI, when you got trained, when you get aligned, when you get skilled, you can become master of using that. Let us say I buy a car and then it goes bad, I go to mechanic. But if I know how to take care of that, how I know small parts and I'm aware about that, therefore I'm talking about not mass production, it is production by masses. So every individual know about, well, as I make you skilled person, so that you yourself in a position to identify the problem, diagnose the problem, and up to certain extent, you yourself will be able to figure out the solution. That's the beauty added by knowledge of the VLSI. Of course, it is difficult because we have to proceed and get skilled, get knowledgeable, use that. But yes, that is the freedom we get to this one. So I'm not dependent on any of these bottlenecks.
Okay. So, okay, sir, this is my final question. Can VLSI design principles be applied to create more sophisticated neural interfaces? And what implications would these have for biomedical applications?
Very good question. Whenever interfaces come, very important thing is the challenges are one technology and another technology. What are the different levels? One technology levels means I'm talking about the energy levels, when I'm talking about the voltage level, when I'm talking about current levels and all those things. Because when you are taking the data transmission from one to another, or any of the thing, let us say when you are talking about the medical, when I'm talking about the microfluidic drug to be delivered at medical part. Okay. So I need a control. When I'm talking about the nanoliter means it should go nanoliter per second or per hour. That much control mechanism, if you want, that is possible by the help of VLSI, that is called MEMS technology. It is called micro electromechanical systems. So you can have everything like micro pumps, okay, which is that delivery gives that level, which are the mechanical system. But technology is advanced now, it is called names. Nano electromechanical, nano means nano level components are there, which is useful for detection of this. Let us say I want to know, I kept certain things at place, and that is going bad and all. Okay, so in the medical field it is very important because the drug is not usable to patient and all. So that kind of nose, I cannot go and smell that thing, but electronic nose you can make, which will be trying to check, not check, trying, it is checking the drug which is kept in the reservoir and tells you, sir, this is not usable now. So that is smell electronically is done with that, and that is possible by that very small sensors, very small mean micro level sensors, which has the sensory layer with connected to that, and it keeps on sensing, and whenever it goes bad or it's going beyond limit, it tells you in your mobile. So it saves patient for or any good thing reaction happening to the patient. This is one example because of the time. There are many things. For a blind person, we have the artificial retina made by the VLSI. Wow, then he can see now. The person who cannot hear, we have the chip can be embedded here. He can, his transplant can be done and he can hear. What you talk about, anything you talk about, there are possibility for available in the medical field. In fact, it's a very well connected with the VLSI, getting all applications, and we are trying to mimic those things which can be done, and it's possible and it's done. So yes, very important interfacing component VLSI is providing you. It's a buffering for gap between this technology and the other technology. It's a buffer, actually.
Yeah, okay. So thank you, sir. Thank you for the useful answers. So the answers are very useful. I hope the answers and all the participants understand about all that. So finally, so on behalf of our organization and all the participants, I extend a heartfelt vote of thanks to Dr. Ravishankar Dudhe for his enlightening presentation on technological advancements in VLSI. So Dr. Ravishankar's deep insights and expertise have significantly enhanced our understanding of the current trends and future directions in the field of VLSI technology. And Dr. Dudhe's ability to illustrate complex topics with clarity and depth is truly commendable. And his discussion on the integration of new semiconductor materials, that potential of VLSI in evolving technologies, and its impact on industries ranging from consumer electronics to biomedical applications has not only informed us but also inspired innovative thinking among our audience. The practical examples of VLSI applications he provided have vividly illustrated the transformative power of these technological advancements in our everyday lives. And we are immensely grateful to Dr. Ravishankar for sharing his valuable time and knowledge with us today. His contributions to the field of sustainable energy and VLSI are of immense value, and his dedication to both teaching and pioneering the research is an inspiration to us all. So, thank you, Dr. Ravishankar, for your engaging and thought provoking session. And we look forward to the opportunity to learn from you again in the future. Your efforts in educating and inspiring the next generation of engineers and researchers are greatly appreciated. So, thank you, sir. Thank you so much.
Thank you. It's my pleasure because whatever we know, if you start sharing, it becomes useful. Because the young minds, they need some inputs and then they start taking from there, and that's the return for us. We don't want any other thing written from them. We want only that they know that these are the things available. They can use it. They can shape their future, and they can enjoy the future with the way they want. You know? And yes, that's the beauty of such kind of talk. Thank you for giving me opportunity, and I'll be happy to come up with the topics which are useful for the young people and making them useful for society and saving mother nature. Whole thing is saving mother nature. How we can save? Then future belongs to us. Otherwise, we spoil our future. So better not to spoil, better to get learned, better to exchange such kind of things, and let them know how their future can be brighter. So I'm happy, and thank you for providing this opportunity. Always very happy.
Yeah, thank you, sir. Thank you so much.
Thank you.